if there are any questions or discussion now, we can talk informally. Get started in just a minute.
Hi. Yes, I've got a question actually, whenever you're ready.
Go ahead.
Oh, thanks. So I just wanted to keep going a bit on this topic of the adhesion to the substrate, not the contact energy. So I don't know, whatever ideas you guys have, because I would be very interested.
So I missed part of that conversation. So what is it that you want to do? You want to have junctional adhesions? You want to model adherence junctions or something like that?
Not exactly. So there is this biological system which I've been working on, and I've been doing this in chaste in the vertex model. So I did this by adding additional energy term, like to keep the cell in place, but I don't like it. It's like what I did basically was imagining that there is like this global attachment point, and the cell can rearrange the vertices, but it can still, but it still is attached. So what it models basically, there are cells which are very adherent, and there is an evidence which they stay in place. They get rearranged because there's stem cells which proliferate, so they want to get rearranged, but they do not leave the place for several months. So I would like to include this part, and I was wondering if I can do it with a cellular pods model.
So there are a couple of things that you can do. One problem biologically is, how do stem cells actually stay in their niche? We don't really understand very well how stem cells stay in their stem cell niche.
Yeah, it's actually about not stem cells, but the cells which are surrounding stem cells, so like they support the stem cells.
So it's the support cells. But it's the same issue, which is you have a lot of proliferation, you have a lot of migration. How do the cells stay where they need to be? And to some extent, I think that's not completely understood biologically. But there are a couple of things you could do. In CompuCell, you could do essentially what you did in Chase. You could use the link concept, and you can create an anchor point. Those anchor points can be anywhere, and you can anchor the cell center of mass to that anchor point. And that will allow the cell to move around a little bit. It could, because you could use an elastic spring anchor, for example. And so that allows the cell to move a little bit, but it can't get very far from its target, its initial position. So that would be the way I would do that. The other thing you could do, if it's really a cell on a substrate, is that you could create links between, you could divide the substrate into small domains, and you can create links between the cells and the substrate, and then those can be dynamic. You can have those be different kinds of functional adhesions. Those could represent something more like a junctional adhesion, a focal adhesion, and then you can have a lifetime. And actually, Gilberto, who was speaking yesterday, has been working with a group modeling cell crawling that way, where he's trying to model the individual formation of the focal adhesions during cell migration. And so both of those methods will work. I don't know if we'll actually get to show you that, but when we talk about links, maybe it's worth asking Julio and Priyam, who'll be giving lectures on links. You might want to email them and ask them if they could cover that, because creating the one thing that you can't do at the moment in CompuCell is have a floating link anchor. So you could create a fixed point of anchorage for a link, which is, I think, what you want here, and then anchor the cell to that. That works. Or you can anchor centers of mass of cells or cell components to each other, or cells to substrate components. The one thing that you can't do is have the anchor point for a free-floating anchor point move. At that point, you're building a full center model, and we're working on getting that released. But I think probably if you're going to do the hackathon, we could sit down together for an hour and work on that together. But it's definitely possible to do that.
Okay, so what you say basically is that if I want to consider this type of adhesion, I have to go three-dimensional, because so these focal points, they would be kind of in the in the bottom, right, in the plane, so not
Well,
attached to
well, no.
other
If you
cells.
use a floater, if you use the anchor to a point function, and I have to say, I hope it still works because I haven't used that one in a long time. But if it doesn't, we need to fix it. If you use the anchor to a point, a floating anchor, you don't have to do 3D. We often will do what I'd call 2.5 dimension, where TJ says anchors work, so you can do it.
Okay.
And I could sit down with you for an hour and show you how to do it, but I think that what we have to do together. The other thing we do a lot of, and you'll see that today, is what I'd call 2.5 dimensional simulations, where you have a 1D plane of cells and another 1D plane on top of it. And so those 2.5D models, you could have the bottom plane be the substrate, non-cellular substrate, and the top plane be the cells, or you could have an epithelial layer with cells crawling on top of it. So using 2 layers, each one of which is 2D, is usually very efficient. It gives you a lot of the benefits of 3D without the computational cost.
Okay, I would actually love to try both options,
Right.
because you never know how it's gonna work, right?
Well, you're in England or in Australia.
I'm in Spain actually.
Oh,
Yeah,
in
so it's a bit, yeah, it's a bit European time. It's a bit tricky with these things.
So then maybe during the weekend, if you're available, would be the best time to meet.
Yes, I'm not going to attend, unfortunately, because
Oh.
of the times, the whole hackathon, but I will be available for, for some hours for sure. It's just like the whole hackathon is too intense.
Right.
So
Right.
yes, would you mind if I send you a follow-up email? And
No,
then
not
we
at
will
all.
see.
Please do.
Okay, thank you.
Okay,
Then that
great.
would be great.
Okay. Any other informal questions while we're getting set up? Doesn't have to be to me. So.
Well,
Okay.
I have a problem signing to NanoHub, and I emailed Hayden about it, but no response. He must be very busy, and I appreciate that. But I'll be very grateful to be able to sign to the NanoHub, although I don't belong to any university.
You don't have to be in a university. Anyone, anywhere in the world can have a
Yeah, I tried with the Gmail, with the Google account, whatever you call it, but somehow, and I submitted, but I didn't get any answer. But maybe that will be resolved over time. I still enjoy the workshop in a passive mode.
Pedro, do you know how to log into NanoHub?
Well, I know that there's been a little bit of problems before with trying to log in with your Google account with the login with Google option before. So if you try to create an account just using your Gmail, like from scratch, instead of just trying to sign in with Google, that might be a little bit easier.
Well, I tried with the Gmail, but we shall see. It's a matter of time. I have patience about it.
Pedro, could you possibly go into a breakout room with Itamar for a minute and see if you can get him set up for
Yes,
use the create account option. Don't use the sign in with Google. Let's just fill out the form. There's a form at the bottom.
That's what I was doing. That's exactly what I was doing. So maybe it's already done because they say 24 hours, and I've done it very late at night yesterday by desperate experience. So Pedro, you can spare your time with me. I'm patient. Passive mode is okay with me. I've done it like last year and I learned a lot. And I've done simulation on your previous meetings, like in July. So I've seen some simulations. I'm not totally lost. Everything is fine.
And do you have a desktop version of CompuCell?
Not yet, but my desktop, my PC is doing problems, so I'm talking to you from the telephone. Anyway, let's take it easy. I enjoy everything.
If you don't
appreciate everybody here.
So if you don't get a response from NanoHub today, send me another email and I'll forward it to the NanoHub administration.
Okay, thank you.
Okay. Sarana? Is it? You had a question? The question was, simulation domain is neutral. So if cells grow without constraint and fill the space, it's because the space of simulation doesn't represent any other surface. Combined pressure from organ surface within cell force. I'm not sure exactly what you mean by pressure from organ surface with cell force. Are you meaning something where you're thinking about pressure, essentially lateral pressure on something like an epithelium, or are you thinking about a pressure perpendicular to an epithelium, or something else, like more mesenchymal? Feel free to unmute and talk.
Okay, hi. I'm unsure. I'm just thinking about like we're doing an organ or like a compartment model. If you're trying to just apply if there's multiple sources of pressure. So maybe it is perpendicular. I'm not quite sure about directionality, but I'm just wondering about multiple pressure fields.
Yes, you can have multiple pressure fields acting at once. And actually we'll start working on that today, I think. Maybe today, late today or tomorrow.
Okay, great. Thank you.
And
Can
then
I try rephrasing her question, maybe, James? How can you
Please,
make
go ahead.
the medium exert pressure to the cells?
Well, I think the medium could certainly exert pressure on the cells, but you could also have tissues push on each other in a whole variety of ways. And you could also apply explicit forces. If you know that there's blood pressure or hydrostatic pressure from lymph or something like that, those can also be represented. And I think we'll either the end of today or tomorrow, we'll do those. So I think you'll get to see those. Again, in a week seems like a long time. It's a lot of everyone's time, but it's still, biology is complicated. So trying to get through all of biology in a week is hard. So there are going to be a lot of things we'll mention, but not go into detail with. And so we do hope that when people have gone through the course and seen what there is, we're happy to support you and help you learn additional material that we didn't get to cover during this workshop. Hey, anything else before we get started? Hayden, you want to take over from that?
Sure. I was just going to follow up on what James actually said. If you do see something during the workshop that piques your interest, but that we don't necessarily have time to go into during the day, feel free to send me or James an email, and we'd be happy to follow up with you after the hackathon about where to find resources for that. We can spare some time to help people, pursue the particular biological interests that they would like to model. We just may not have time to do it, during the day this week. All right, so I've got 10:01 or 10 o'clock exactly.
It's okay if we slip by a few minutes. It's all right. Why don't you do a brief intro and then I'll take it.
Sure. All right, so hello everybody. Welcome to day 2 of the 2022 CompuCell3D modeling workshop. Just as a quick reminder of our normal notes here. These workshop sessions are all being live streamed and recorded for future distribution. So just keep that in mind as we move forward today. If you have not yet had a chance to join the Slack channel, I think everybody has. So I think today might be the last day I say this out loud. There is the link there, and I will put it in the chat. Let me grab that just for anybody who may still be looking for that Slack link. Okay, maybe the Slack is in the chat. So just a quick overview of today. So we did a little bit of rearranging of the schedule last night because we wanted to spend a little bit more time going over the cell division portion of Gilberto's talk. We got a little bit behind schedule yesterday, so we're going to make that up today in session 2. Just a quick overview of what we're looking at today. Module 2.1 we'll talk about a couple of various applications that CompuCell has been used for, a couple of different published works, just to kind of give you a feel for what has been done with CompuCell already, as well as a little bit of intro on how to start thinking about writing your own biological models in CompuCell and just how to model them more generally. Module 2.2, again, we'll review cell growth, and then we'll spend some time going over cell division. Module 2.e, we have some open hackathon prep time today. So I just sent out an email. Hopefully all of you got that with materials from module 2.1, but also with a little bit of recording with a note about the hackathon session today. If you've already presented your hackathon talk, but you would like to re-present it today, or if you have a hackathon lightning talk prepared that you are wanting to do sometime this week, we can have a couple of people present today. I will say, if you've already done the 7-slide template, we're going to cut it down to 3 slides for today, so things go a little bit quicker. So just your biological background slide, your modeling goals slide, and your potential teammates slide. We'll go over that again at the beginning of the session. Module 2.3 and 2.4 today then will be about chemical gradients with Pedro Casto. I do want to make one extra note here. This was in the announcements email this morning. We're making a slight change to the format for questions during each session today, just so that we can kind of keep things on track. Moving forward, all questions entered into the Zoom chat will be moderated by myself. So I will be monitoring the chat for questions, and when there is an opportune time to jump in, I will jump in with sort of summarized versions if people have similar questions, to kind of get those addressed quickly and move on. So if you do put a question in the chat and it just sits there unanswered for 5 or 10 minutes, please do direct message me. Sometimes we miss these things, especially if a lot of people are talking at once. If you have something really urgent, or if you're super confused about something that the presenter just said, please use the raise hand option to get the presenter's attention directly. But otherwise, we will do questions moderated through the chat today and for the rest of the workshop. Just a couple of reminders on links here. If you lost the link to the CompuCell tool, I will put that one in the chat too. And then we also have the link there to the desktop downloads if you would like to work on getting that set up today during the breaks.